we're going to go over example 1 from notes P.5. The set of real numbers for which an algebraic expression is defined is the domain of the expression. So that's what the domain is. You can think of the domain as any values for the input which don't break the function. Okay, that's what the domain is. We can express the domain using inequality or interval notation. In example 1, we're going to focus on using interval notation. Okay, so in example 1, we're asked to find the domain of the given algebraic expressions. And to do that, we're going to think about values for x that are excluded. Okay, so if we have the expression given in letter 1a, 3x plus 2, are there any values of x for which the expression is undefined? Are there any real numbers for x that if we put in for x would break 3x plus 2? In this case, there are none, so the domain is all real numbers. So normally we can put a big capital D, that's the domain. And if we're going to use interval notation, we'd have the interval from negative infinity to infinity, and we would use parentheses with those negative infinity and infinity. In letter B, we have the expression the square root of x plus 5. We want to think about all values of x for which the expression is defined. So if we have a square root, we have to remember that we cannot take the square root of a negative number. So in order to find the domain, we can solve an inequality. That inequality will be x plus 5 is greater than or equal to 0. So whatever is underneath this radical, we'll take that expression and we'll solve the inequality x plus 5 is greater than or equal to 0. We can take the square root of 0, just not negative values. Solving this, we'll subtract 5 from both sides, and we'll get x is greater than or equal to negative 5. And if we want to put that in interval notation, we're going to do bracket, negative 5, that's the smallest value, and it goes up to infinity, goes on forever, and then we'll use parentheses. Okay, so that's the domain for the second expression. And the third expression, we have a rational expression, right? We have the ratio of two polynomials. So this is a rational expression, which we are going to talk about a little bit more in this lesson. So the issue here with a rational expression is it's the same thing as with a fraction, which is we cannot divide by 0. That will be undefined. So we're going to focus on the denominator here, which is x squared minus 9, and we want to find out values that are excluded. Those would be the values that make the denominator 0. So we're going to do x squared minus 9 is not equal to 0. And we're going to solve this. There's more than one way to solve it. We can factor. So if I factor this, I'd get x plus 3. This is a difference of squares times x minus 3 is not equal to 0. And this would give me two little equations. Wait, let me fix that. X plus 3 is not equal to 0, or x minus 3 is not equal to 0, which would be x is not equal to negative 3, or x is not equal to 3. So if I wanted to summarize that, I could say x is not equal to plus or minus 3. Putting that into interval notation, this is my solution on the real number line. I can put negative 3 and 3. Those are the only two values that are excluded, and I want every other value. That's how it would look graphically. And on interval notation, we'd start with negative infinity. We take all the values up to negative 3. We use parentheses because negative 3 is not included. Then we'd have union. The next interval would be from negative 3 to positive 3, both with parentheses because the endpoints are excluded. Union 3 to infinity. We could also solve this without factoring. So let's start over here. If I have x squared minus 9 is not equal to 0, I could add 9 to both sides. X squared is not equal to 3. And then if I take the square root, x squared is not equal to 9. And then if I take the square root of both sides, I'll get x is not equal to plus or minus 3, which is the same place that we got when we factored. So either method to solve will be fine.